Hey guys, in this video I'm going to show you how to answer the Maths Method Sample Exam 2 External Response Question 2. We've got a solid block in the shape of a rectangular prism has a base of width x centimeters. The length of the base is 2.5 times the width of the base. The block has a total surface area of 6480 centimeters squared. Show that if the height of the block is h centimeters, then h is equal to the given rule. Since we know what the total surface area is, we need to use the formula for the total surface area to work out the rule for h. The formula to find the total surface area of a rectangular prism is 2 times its length times its width plus its length times its height plus its width times its height. The total surface area we know is 6480, and so this is going to equal 2 times, and then from here what we need to do is sub in the length, the width and the height in terms of x and h. And so the length times the width is going to be 5x squared on 2, and then plus the length times the height is going to be 5xh on 2, plus, and then the width times the height is going to be x times h. Expanding the right hand side, we're going to get 6480 is equal to 5x squared plus 5xh plus 2xh. Rearranging this, we're going to get 6480 minus 5x squared is equal to 5xh plus 2xh, which is 7xh. And now dividing both sides by 7x, we're going to get h is equal to 6480 minus 5x squared over 7x, as required. Part B. The volume v cubic meters of the block is given by v of x. Given that v of x is larger than 0 and x is larger than 0, find the possible values of x. To find the x values where v of x is going to be larger than 0, we can set up this in the calculator and then solve for x. First, let's define v of x. And now we can set v of x to be larger than 0 and then solve for x. And so solving for x. And so when x is between 0 and 36, or when x is less than minus 36, v of x is going to be larger than 0. But we want x values to be larger than 0, and so the answer is going to be for x values between 0 and 36. Now, honestly, I'm not sure why this question is worth 3 marks, but if we had to show working out, then we would say set v of x to be larger than 0, and so 5x times 6480 minus 5x squared over 14 would be larger than 0. Multiplying both sides by 14, we would get 5x times 6480 minus 5x squared is going to be larger than 0. We can factorize the brackets, and using the calculator we can do this. And so factorizing this, and so we can rewrite this as 5x times minus 5, which is going to be minus 25x times x minus 36 times x plus 36. And this has to be larger than 0. We now have a cubic inequality. To find the x values where this cubic is going to be larger than 0, we need to sketch its graph. The cubic function is a negative and it's written in factorized form. And so the x-intercepts are going to be at x is equal to 0, at x is equal to 36, and at x is equal to minus 36. Sketching this function, we can see that v of x is going to be larger than 0 for the values where x is larger than 0 when x is between 0 and 36. And so the answer is going to be for x values between 0 and 36. Part C. Find dv dx expressing your answer in the form dv dx equals ax squared plus b, where a and b are real numbers. To find dv dx, we can just use the calculator. And so dv dx, in the form required, is going to be minus 75x squared over 14 plus 16200 over 7. Again, I'm not sure why this is worth 3 marks, but if we had to show working out, then what we would need to do is expand the top brackets of v of x And so using the calculator, this is going to be and so we can write v of x in equivalent form as 16,200 times x over 7 minus 25 x cubed over 14. And so deriving this using the power rule, this is just going to be 16,200 over 7 minus 75x squared over 14. And so rearranging this, we're going to get dv dx is equal to minus 75x squared over 14 plus 16,200 over 7 in the form required. Part D. Find the exact values of x and h if the block is to have maximum volume. To find the maximum volume, we need to let dv dx equal 0 and then solve for x. And using the calculator, we can work this out. Solving for x is equal to minus 12 times root 3 or 12 times root 3. We know that x is larger than 0, and so therefore x has to equal 12 times root 3. From part A, we were given the rule for h. We were told that h is equal to 6480 minus 5x squared over 7x. And so subbing this into the rule of h, we can work out the value of h. And so given that x is equal to 12 root 3, the value of h is going to be 120 times root 3 over 7. And these are going to be in centimeters. And that's it for this video. I hope you found it useful. Now, if you guys want to learn or practice more exam-style questions related to finding the minimum and maximum values, then you can easily do this by logging into the Maths Methods Club and choosing differentiation from the main topics, and then clicking on minimum and maximum values. For extended response questions, go to question type and select extended response. Here, you're going to find all the past exam questions related to minimum and maximum values. Go through these questions because this way you're going to be better prepared for your SACS and exams when it comes to answering these types of questions. And if you get stuck, you can just watch the video solutions. Thanks for watching, good luck, and I'll see you guys in the next video.